I would like to ask some people on stage who have worked together since now, I think, 6, 7, 8 months for very intense periods. We have met weekly for a while. Now we're meeting bi-weekly. We have met in France in person to talk circular economy between 5 initially corporates. Now 4 of them are here today. And with that, I would like to ask on stage Marcel from Novelis, our moderator Raoul from Plug and Play, Eric from AGC, Bastian from Motherson, and Roberta from Porsche, who over time have become professional friends of ours. And now they will tell you a little bit more about the project. And Raoul, I will hand over the microphone to you for moderation.
Thank you, Fabian.
Ooh. Yeah, I was not sure if you look for the microphone or for one more chair.
Yeah.
Great to have everybody here. Here you go.
Okay.
Oh, no, let's do it this way.
Yeah, please. All right, perfect. Just let me get the seat. Okay, for the next 20 minutes, I'm very happy to share the scenario with the key people making this collaboration bucket and this collaboration project. So I'm very happy to be with you here. And basically, just going straight to the point, this collaboration bucket was born to increase the use of recycled materials in our vehicles, right? So just having this in mind and how we at the start about embrace innovation after the initial call from AGC saying, okay, we have to do something, we invite to our partners to collaborate here. So this is setting up the first project in this kind of characteristics. So this led to this panel that we have today. Fabian was introducing you, so I don't need to repeat the introduction. So let's kick off the panel with the idea of increasing the use of recycled materials, and we are gonna put something else in our minds, the car-to-car circularity vision. So this is an ambitious project, and we can think that there are some advantages. For example, just to increase the resilient European supply chains, also to see what kind of environmental benefits we can get with this, but also it possesses a lot of challenges. For example, feedstock availability, it has also the technical challenges. So with this small introduction, I would like to ask our initiator of this collaboration bucket, AGC, in your case, Eric, how is your vision? How was your vision for this? How was the idea behind to start this?
So, good afternoon to everybody. Thanks to my colleagues and all the job we did, because it was very interesting collaboration. So, let's say that AGC, we start some years ago, recently, with sustainability and recycling the glass. And when we see the difficulties we have more and more, we see that it's impossible to go alone. So going in the automotive sector, we start with the building sector because AGC is a big group and automotive is a big part of it. So we see that the automotive is a quite complex story. And this quite complex story, if we approach that alone, it will be very, very difficult. And the glass is a cheap product somewhere. So the financial interest to recycle only the glass is not there. So we have to look globally how we can approach that. So globally, we need to work together. This is the only possibility.
Perfect. And also, we have only one OEM here. So I guess that Roberta from Porsche, your vision is very special within this collaboration bucket. So I would like to know more, how do you see this initiative?
So we at Porsche, we strive for conservative use of resources to keep them as long as possible in use. So it is very important for us that our cars have a very long lifespan, and of course, therefore, the materials in them as well. But apart from that, we also really work hard on circular economy in different fields. So we look, for example, on circular material use, which is one of the topics we have covered together, but also the remanufacturing of parts is one topic there which we do cover, and overall processes and business models which helps us to really push that topic forward. So one project example would be the circular battery, where we work on practices to really have a circular approach there. Then other fields where we really close the loop on specific materials. And I think this collaboration has been especially interesting because we have worked together over all the materials, and I think that is really key here, collaboration with all together on board with an open mind striving for circular economy.
So coming back again with the idea of car-to-car circularity, we know that it has a great potential, but also we know that there is a big challenge that we don't yet recycle enough material from old vehicles to make new ones. So maybe my question for you, again, as you have a special opinion here in Vision, is that what maybe one, two most important things we have to do now as the automotive industry to achieve this use or increase the use of recycled material and achieve the goal of this car-to-car circularity?
Yeah, so to really get to that goal, a very good goal of car to car, a great vision for us all, we think that we have a need of a certain mindset within the whole industry, that everyone is very open towards innovation, open for new technology, new material, and new applications there, so that we really work on those topics together. And then we think that there will be a knowledge increase, and all together will expand our knowledge on the areas where we might still lack some experience yet. And with that knowledge increase, then we can really push the transformation together. And we think it's important to work on closed loops and open loops as well, just to get the material increase higher in terms of recycled content within the cars.
Yeah, I think that we have a lot of learnings, and this is one of them, also the vision behind. So maybe feedstock and supply chain challenges. Let's go to move the angle of our project, of our collaboration project. So we have been talking a lot during the last past months, and one of the things that AGC and Novelis have been highlighting is the importance of having good materials, high quality materials to be recycled. And this is a significant bottleneck that the recycling industry face in order to find solutions. So referring to this question, Eric, for you is now your turn. How we can create more reliable and robust supply of recycled materials?
So to give first a word, so for 1 ton of glass, we save 1.2 tons of raw material. So it's to give the importance to recycle. So if we recycle 1 ton of glass, we have 1 ton of glass, of new glass, but we save 1.2 tons of raw material from the nature. So the importance to recycle is huge, but we can only recycle in the closed loop if we have good quality. To achieve this good quality, so we need to change the mind, because actually the way the glass is collected is totally different from what we have to do to go. So we have to change our mind, to change the technology, to improve the technology. Otherwise, we will not be able to achieve a good business model and have enough glass, enough percentage of glass or other material from my colleagues to be purely recycled. That's the problem.
Mm-hmm. And if we aim closed loop system, I guess that we need to have the thing and also to cover that we need industrial scale recycling solutions, and also to make more efficient the current solutions that we have right now for the dismantling. I think that there is a challenge here in your case with the closed loop, because you were referring at this. But Marcel, in your case, in Novelis, you have been developing this closed loop system with many of your customers through the ACP platform. Like, it would be extremely nice to share your view and your knowledge and experience, and also what can we get here to increase this use of recycled materials.
Let's start with the good one. Fortunately, aluminum is a material that is infinitely often recyclable. So all the material, all the aluminum that has been used in the past in vehicles or in other applications can be reused if done properly. So that's a good part. Also, on the positive side is whenever we recycle aluminum, we save 95% of energy versus using new raw materials. So very positive aspect on why we should be doing or why we should be focusing on circularity. On the negative side, aluminum in general is a heavy contributor to a relatively bad CO2 footprint, so we have a responsibility as aluminum producer. So our goal always has been to collect as much aluminum as possible and return it into our operations to be able to provide our customers with aluminum that comes with a very low CO2 footprint. Now, there's two types of recycled material that is interesting. Number one is the material that comes from the press shops from our customers. So we send aluminum coils to our customers in their press shops. They stamp their parts, and whatever is left, we collect, remelt, and reuse. That's easy, but that's also limited in terms of volume. Now, the second part is all the material that has already been on the road, and how do we get that back? So in order to tackle that problem, together with ThyssenKrupp Material Services, we've started a platform that is called Automotive Circularity Platform, or ACP, with the goal to bring all the partners along the supply chain, along the value chain together, from the recycler to the dismantler, to the sorter, to the shredder, to the material company. And by doing that, we increase the volume of aluminum, we increase the quality of the available scrap, and we also increase the business case for doing such an operation. And the main goal of the Automotive Circularity Platform is basically to increase the value of that scrap material by bringing all the players together. And by doing that, we create an incentive scheme for a dismantler to perform extra dismantling steps that come at extra cost for the dismantler. But we are able to do that in an economical, useful way. And this will allow us to have better quality, more segregated material, and new additional material stream that can be used for putting back into end products.
Moving forward the conversation, because during the last months, we extremely realized how difficult it is to dismantle many parts of the car. And we also put in our minds like the motto of design to recycle. So with this, we have corroborated that having monomaterial plastics and also monoalloys aluminum part will reduce the entry point for having more efficient recycling solutions. So I think that here really touches Motherson in this case, because I mean it's quite complicated to recycle the plastics that they are together. So from your perspective, how you introduce or apply these principles into a more design to recycle applications in the vehicles?
Yes. So first of all, to apply this, we need to be open for rethinking how polymer products in the vehicle interior are made, are designed and manufactured. And at Motherson, we are currently producing sustainable interior and polymer components. And we are working on it to have a constantly decide that it's constantly better to align with the design to dismantle principles. And one big challenge there are the current OEM specifications, especially in the premium segment, because they're
just for references.
Okay, sorry. Because their multi-material usage and irreversible bonding are still quite common, and this makes recycling very difficult for us. Because when we shred the parts at the end, at the recycling process, then we receive a large volume of multi-material flakes, and these flakes are at the moment not recyclable or very hard to recycle. To reduce these flakes and receive more mono material flakes at the shredding, we need to keep in mind a few focus points. The first one is, an obvious one I would say, we need to reduce the usage of multi-material and use more monomaterials wherever possible, of course, yeah. And also, if it's not possible to use monomaterials, then we should prefer mechanical joining over chemical bonding. And speaking about bonding in general, we need to reduce the irreversible bonding between parts in general, especially between different materials and to decors, or decorative materials, I would say. But we also have to think about our currently manufacturing and assembly lines, because in our workshop, where we talked about it before, in France, we saw that the door panel we dismantled had some stack-ups with different materials in different layers. So first a PP part, for example, then a PC-ABS part, and then a PP part again. And if we build clear groups there, or monomaterial groups first, so assemble all PP parts together, assemble all PC-ABS parts together, and just after this, we produce the whole door. So we assemble all these parts together, and then the dismantling is easier to handle because we just have to dismantle these few last steps, I would say. Also for electronic parts, it would be good if all these parts would be in one dedicated group, because then these parts are also easier to recycle. And looking a little bit to the future, when the chemical recycling will improve over the time, then this will also help us for the recycling of the multi-material stack-ups, because with chemical recycling we could handle even complex waste streams better. Yeah. And at Motherson, we want to be the preferred tier 1 to build these solutions, these sustainable solutions, and therefore we have to work in such collaborations together with our customers and build clear structures to align with the design to dismantle principles. Yeah,
that's a really good point.
Yeah.
Maybe quickly with you, Marcel, because it's basically touching the same, right? It would be nice to have mono alloys of aluminium there, right? What is your view here?
So in the automotive industry, we usually have two types of aluminum. We have 5000 and 6000 when it comes to sheet material. So it's two different families of alloys. Very often we see that a part is made out of two different types of material. So the inner part is one type, the outer part is another type, which comes with certain challenges in end-of-life recycling, but also during the production process. So coming back to the example I mentioned before with the press shops, right? So you have a press shop that deals with two different types of materials. So whenever there is waste coming from the press shop activities, that waste needs to be segregated, separated, in order to have still clean material streams coming back to us or to another aluminum supplier. So that's one challenge. This is extra effort, this is inefficiencies, and if not done properly, you basically screw up all the quality, the properties of a good aluminum. Now, secondly, on the end-of-life recycling part, coming back to what already has been said, I mean, there's joining technologies which makes it very difficult to separate different types of alloys. Okay, there is now new technologies that allow with optical sorting or with other innovations to be better in sorting different types of alloys, but it's still not perfect. And whenever it's not perfect, you dilute the quality and you lose out on the properties. So therefore, having a monomaterial will allow for better, more efficient pre-consumer scrap retrieval, but then also on the end-of-life recycling side to maintain the quality and the properties of the alloy.
Yeah. So if I still have time, no. Okay. Okay, it was super interesting topic. I wanted to give a conclusion from all of you, an actionable step. But if you want to hear that, please go to the booth that they have. They will be happy to teach you more and to tell you more about this beautiful collaboration bucket. So thank you very much to all of you.